In the vast universe, only a few planets possess something as extraordinary as Earth. An atmosphere thick enough, stable enough, and uniquely balanced to support life. We cannot see the atmosphere, nor can we touch it. Yet every breath we take, every warm ray of sunlight, and every drifting cloud is proof of its presence. The atmosphere holds heat, blocks harmful radiation, creates weather, and shields all living things from dangers that come from space. Today, we begin a journey from the ground beneath our feet, through every layer of the atmosphere, and all the way to the edge of space, to understand this great protective system of our planet. What is the atmosphere? The atmosphere is a vast envelope of air that surrounds Earth, forming a continuously moving shell from the surface all the way to the boundary where space begins. Although invisible, the atmosphere extends tens of thousands of kilometers above Earth. Satellite measurements show that traces of the atmosphere can still be detected around 42,000 kilometers above the equator and around 28,000 kilometers above the poles. The atmosphere is mainly made of nitrogen, oxygen, argon, carbon dioxide, and water vapor, together accounting for more than 99% of all atmospheric gases. The remainder includes rare gases, ions, and tiny particles of dust that play important roles in cloud formation and chemical reactions. As altitude increases, air becomes thinner, pressure drops rapidly, and temperature changes dramatically. These variations create the natural boundaries that separate one atmospheric layer from another. The 5 layers of the atmosphere. 1. Troposphere. The troposphere is the lowest layer of the atmosphere, the layer where we live, and the birthplace of all weather. It is around 8 kilometers thick at the poles and can reach up to 15 kilometers at the equator. About 90% of all atmospheric air is found here. This is also where almost all water vapor is concentrated, making clouds, rain, fog, and storms possible. Temperatures drop steadily with altitude, from around 15 degrees Celsius at the surface to nearly minus 55 degrees Celsius near the top of the troposphere. This temperature difference drives powerful convection currents. Warm air rises, cool air sinks. These rising and sinking motions form the engine behind global weather. Monsoons, tropical cyclones, thunderstorms, snowstorms, all of these happen within the troposphere. Commercial airplanes often fly near its upper boundary to avoid turbulence and to save fuel. 2. Stratosphere. Above the troposphere lies the stratosphere, extending to about 50 kilometers. Unlike the layer below it, the stratosphere is extremely stable, with almost no storms or vertical mixing. Here, temperatures increase with altitude because ozone absorbs ultraviolet radiation from the sun and converts it into heat. The ozone layer, Earth's protective shield, resides inside the stratosphere. It absorbs most UVB and UVC radiation, which can damage DNA, cause cancer, and threaten the survival of nearly all life forms. Without ozone, Earth's surface would be exposed to lethal levels of solar radiation, much like the barren landscapes of Mars or the Moon. High-altitude aircraft and weather balloons travel through this layer because of its smooth, predictable airflow. Topic 3. Mesosphere. The mesosphere stretches from about 50 to 85 kilometers. It is the coldest region of the atmosphere, with temperatures dropping to minus 90 degrees Celsius. This is also the layer where most meteoroids burn up. Every day, tons of cosmic dust and rock enter Earth's atmosphere at extremely high speeds. Friction in the mesosphere causes them to heat up and burn, creating the bright streaks we call shooting stars. 4. Thermosphere. The thermosphere is the layer where the atmosphere absorbs the most solar energy. Temperatures can rise above 1,500 degrees Celsius, but because the air is so thin, a human would feel almost no heat at all. This layer contains the ionosphere, which reflects radio waves and allows long-distance communication. The thermosphere is also home to one of Earth's most beautiful natural displays, the aurora, triggered when charged particles from the solar wind collide with atmospheric gases. The International Space Station orbits Earth within this layer, at around 400 kilometers above the surface. 5. Exosphere. The exosphere extends from about 600 kilometers to 10,000 kilometers. It is the outermost layer of the atmosphere, where air becomes so thin that molecules can travel hundreds of kilometers without colliding with one another. Many high-orbit satellites operate within this region. Atmospheric composition and modern changes, expanded to deepen scientific reasoning. The atmosphere contains a remarkably precise balance of gases, a chemical recipe that allows life to exist. Even slight changes in this balance can make Earth warmer, colder, or even uninhabitable. Nitrogen stabilizes the environment. Oxygen supports animal life. Carbon dioxide, although tiny in amount, plays a crucial role in trapping heat through the greenhouse effect. Water vapor shapes weather and climate. Ozone protects life by blocking UV radiation. However, over the past 150 years, the concentration of CO2 has risen dramatically, from 280 parts per million in the pre-industrial era to over 420 parts per million today, the highest level in 3 million years. This increase is warming the planet, melting polar ice, raising sea levels, and intensifying extreme weather events. The atmosphere reacts quickly to human activities, burning fossil fuels, deforestation, and industrial emissions, and these reactions influence ecosystems, biodiversity, and human health. Understanding how atmospheric composition changes helps us predict future climate conditions and guides the global effort to protect our planet. Atmosphere and weather, how Earth works, expanded for scientific clarity and educational purpose. Weather is the direct result of interactions between heat, moisture, and air movement within the troposphere. It is a vast energy system constantly in motion. Winds form due to pressure differences between warm and cool regions. Tropical cyclones arise when warm oceans provide enough heat and moisture to power rotating storm systems. Monsoons occur because land and ocean heat up at different rates. The jet stream, powerful high-altitude winds, steers weather systems across entire continents. These processes influence one another through a complex interconnected network. That is why weather can change quickly and why forecasting remains a scientific challenge. By studying atmospheric dynamics, we improve our ability to predict storms, reduce disaster risks, and adapt to climate change. Atmosphere and life. Earth's protective shield, expanded to strengthen emotional and scientific impact. The atmosphere not only makes life possible, it protects life every moment. It blocks harmful UV radiation, slows down incoming meteoroids so they burn up in the sky, regulates Earth's temperature, and provides oxygen for breathing and carbon dioxide for photosynthesis. Without the atmosphere, Earth would be a dead world, frozen like the moon or scorched like Mars. The atmosphere is a silent but powerful partner of life on Earth. Though invisible, it shapes every moment of our existence. The atmosphere is incredibly thin, no thicker than the skin of an apple when compared to Earth's size. Yet this fragile layer sustains over 8 million species and protects them from the harsh conditions of space. The future of the atmosphere is the future of humanity. Every action we take, big or small, affects climate, weather, and the stability of life on our planet. Let us protect this extraordinary shield, for it is the greatest gift Earth has given us.